Hello guys, welcome to A-level physics and mathematics. In this section, I will break down vector and vector and scalar physical quantity for you guys. So as you can see, there is a couple of difference between vector and the scalar quantity. So meaning that scalar, let's say a vector scalar quantity. So scalar quantity means a physical quantity which can be expressed using only a magnitude of physical quantity. So we can express a scalar physical quantity using only, don't forget this one, and then only magnitude. We can express scalar quantity using only magnitude, or we can express only size and the amount. So, like I said, a physical quantity, scalar physical quantity can be expressed or fully expressed using only magnitude, or it may be expressed by using size or amount without any direction. So, which means the scalar physical quantity. So we can express this one using, or simply express using a number in the unit. As you can see, we can express this number and units. We don't need to use, or you don't need to use any direction of that physical quantity. And as you can see, there is a couple of expressions. There is a couple of examples over here, which is mass. Mass is one of the scalar physical quantity. And then temperature, we will see a couple of examples later on. But this is a couple of examples can be expressed using only number and its unit. So this is a couple of example, and then we can use, as I said, we can express this using a number, and then a number and its unit. So you don't, as I said, you don't need to specify, or you don't need to use any specific direction. Like I said, like let's say a north or up or left or down or east or west. You don't need to use any direction to express this scalar physical quantity. So there is a couple of example over here, or a list of scalar physical quantity. As you can see from here, there is a couple of, or there is a list of scalar physical quantity with an SI unit. So the first is mass, and then we can measure mass with, the SI unit of mass is kilogram. We can express it by kg, and then time. The symbol of time is T. I believe you are familiar with that, and the SI unit is second. And then temperature. The SI unit of temperature is Kelvin, but most of the time we can use, or commonly we can use what was that, degree centigrade. As you can see, degree centigrade is, even if we are using over here, but it's not a SI unit. But most of people use what? The degree centigrade, but the SI unit of temperature is Kelvin, and then speed is symbolized by V, and then SI unit of symbol is meter per second. And then distance distance, I believe you are familiar with that. Let's say an object moved from a point A to point B, then there's the kind of a distance from point A to B. We can express this using only its magnitude as well as a unit. It's only magnitude, meaning that we can express this using only its unit as well as units, and then a number. So let's say a distance from A to B is 5, and then, as I said, the SI unit of distance is meter. As you can see, SI unit of distance is meter. So we can express this distance using its quantity, or it's a number, and then or that it's number and then units. And another scalar quantity is energy. We can express energy using E, meaning that the total energy. I believe you are familiar with this guy, and then energy or total energy can be expressed by using E. And then this is a potential energy. Maybe we can express, in classical physics, we can use, that potential energy can be expressed, look like this, but we can express, even if in classical or mechanical physics, we can use, U, and then K is for energy. Those are symbol of energy, and then its SI unit is joule, which is equal to with Newton meter, and then we can express also this one is kilogram meter square per second square as well. And then the other SI, the other physical or scalar physical quantities is work, and then its SI unit is joule. And the other physical quantities or scalar physical quantities power, and then its SI unit is watt, or we can say, or we can express using joule per second as well. And then other SI unit or scalar physical quantities are like electrical or electric charge. We can express this small q or uppercase or lowercase. It doesn't matter, but we can express. It depends upon the physical quantity that we are trying to express, but we can express this one using lowercase or uppercase q, or which is capital or small. And the other physical quantities is a density, or which is rho. I believe most of you guys are familiar. And then rho is a symbol for density. And then SI unit is kilogram per meter, kilogram per meter cube, which is SI units of density, and then volume, which is expressed. You can measure with. You can. Its SI unit is meter per second, cubic meter, or we call it meter cube. And then the area of kind of, maybe most of the time we can use area. Maybe if the surface is a rectangular or a circular surface, we can use area, or we can calculate the area of the. So let's say if you are trying to measure the rectangular surface area, we can express this one is like, let's say this is a base. This is and height, and then this, let's say this is a base. So the area of rectangular surface is, as you know that base time height, and then area of the circle is equal to pi r square, which is, and then we can express this using square meter, or meter square is the SI unit of area. And then frequency SI unit is hertz, or we can express using per second. This is called a per second, or we can express this one look like this. So frequency or an SI unit of frequency or that it is per second. And then pressure is one of the scalar physical quantity, and then SI unit is Pascal, or we can express Newton per meter square. And then finally, we can say a couple of scalar physical quantity, which is heat, entropy, and specific heat capacity. Specific heat capacity is also a scalar physical quantity, and then those are an SI units of this physical quantity. So those are a couple of, a list of scalar physical quantity. Let me know if you have any other physical quantity in the comment section. I'm happy to learn from you guys. So these are, like I said, these are a couple of, or a list of scalar physical quantity. And then the other physical quantity, like I said, is a vector physical quantity or vector quantity. So vector quantity is a physical quantity which can be expressed using a magnitude as well as the direction of that physical quantity. Okay, maybe if you are trying to express, or if you are trying to express a couple of physical quantity, let's say displacement or distance, or displacement or velocity or acceleration, you need to express those physical quantity using a magnitude and then as well as a direction, unless maybe it may be maybe people maybe you may not understand this is a velocity or a displacement or an acceleration of that quantity. So like I said, physical quantity, the vector physical quantity, we can express this one was magnitude and direction of a quantity or a physical quantity, meaning that we can express this vector quantity, or we need to express fully with a magnitude as well as direction. So basically, this can be sometimes written as, and like as you can see here, there is an arrow, and then you need to, to express this physical quantity, we need to use an arrow up, like above the symbol, basically. It's not, let's say, velocity. As you can see, this is a symbol of velocity. Let's say, let me express here. You don't need to use like this. You need to write an arrow up here to express this physical quantity. Let's say another physical quantity as well. This is just for instance, we can take a velocity because it's a vector physical quantity. So as you can see, there's a couple of examples here, which is expressed on 40 meters per second to east, right? To east, meaning that we're trying to express a velocity of a body or an object. So this is a physical quantity or a vector quantity because we did represent with using a magnitude as well as a direction. And then here we have a force far distance of 10 meter, 5 meter, whatever. And then we did express this one using direction. Okay, this is a direction, and then this is a magnitude of a force, and then these are this 40 meter per second is it's a magnitude as well as this is a direction. So we can express this vector quantity using direction, maybe up, down, later, down, up, and then left, right, or east, west, north, and south. We need to write those direction to express this vector quantity. So there is a couple or a list of physical quantity for you guys. So this is a list of vector physical quantity. The first one is a displacement. We can express this displacement using S or D. Some people use a D or R. It depends upon the physical quantity that you're trying to express. But sometimes also we can use a theta if the surface is a spherical surface. Maybe we can use a theta as well. But it depends on the surface. But what I just wanted to explain for you guys is displacement is a vector physical quantity, and then we can use to express a displacement using a direction as well as a magnitude, and then symbolize it by S. Most of the time we can use S to express a displacement, and then a velocity. All of you guys, if you are a high school student, maybe you are familiar with this symbol as well as physical quantity. So it is symbolized by V, and then above R. We can use like this. We can write V, and then we need to write an arrow above the V. And then acceleration is another vector physical quantity. As you can see, the symbol is here. But there is an SI unit over here. The displacement is the SI unit of displacement is meter, and then the SI units of velocity is meter per second, and acceleration, the SI unit of acceleration is meter per second square. And yeah, those are the SI units of a vector physical quantity. And the other vector physical quantity is force. Force is an SI unit of force is Newton or kilogram meter per second. Kilogram meter per second square, which is expressed look like that. And then momentum is another vector physical quantity, and then the SI unit of momentum the SI unit of momentum is kilogram meter per second, which is an SI unit of momentum. And then another SI unit or another vector physical quantity, electric field, magnetic field. Those are a couple of physical quantity, and then we say that those are. It is basically it's a vector physical quantity. We can express electric field by using E, and then B for magnetic field. And the SI unit of electric field is Newton per coulomb, or Newton per meter is an SI unit of electric field. And then the SI unit of magnetic field is Tesla. So we can express Tesla using T or Tesla, and represent it using the T, like I said. So the other vector quantity is weight, and then we can represent weight using W plus arrow above the symbol, and then its SI unit is Newton. So those are a list of vector physical quantity. There is a couple of also. There is a couple also, which is torque, angular velocity. We can represent using omega arrow, and then impulse. This is impulse is represented by J or capital J. Basically, most of this vector quantity, or I would say a vector quantity represent using uh, was that the uppercase letter, but in some case, as you can see, for gravitational field strengths, we can use a small or lowercase letter. But yeah, in most cases, we can use uppercase plus arrow. And then the other guy is gravitational field strength, which is represented by G plus arrow. Let me know if I made any mistake. I'm happy to learn from you guys. And then current density is represented by J, and then its SI unit is ampere per square. So I just want to revise this session. In this session, I just want to let you know the basic difference between scalar and then vector quantity. Let me know if you need any additional information, or let me know if you have any thing that you are that you want to uh, or that you want to mention, or that you want to add in vector or scalar quantity. I'm happy to learn from you guys. If you are not, if you are happy with this session, or if this session helped you, please subscribe this session. This video, and then share with your friend. Also, just we'll maybe next time we'll continue the session, another topic. So that's all for today, guys. And then if you have any other question, I will put in the description my LinkedIn as well as Telegram. Maybe if you have any question regarding with classical physics or quantum physics. I'm familiar with quantum mechanics, quantum information, group theory, and then classical physics. We'll see all basic classical physics, and then let me know if you have any group assignment or individual assignment. I'm happy to help you. Thanks so much for your time for you guys, and then have a great day. Goodbye.